Most of you hopefully know by now, I'm Jessica. I'm a summer intern. I've been working with UN on a few projects related to the integrated data viewer, which I'll just call the IDV. The IDV is a very large piece of code. It's about 1.5 million lines long. It runs using JDK8, which is the same version of Java that BlackBerry was very, very proud to be running. You know, those little like business person computer cell phone things. So realistically, you could keep a team of like 3 to 5 software engineers busy full-time maintaining this code. But we just have Ewan. And he does a really good job, but it's inevitable that he's not going to get everything. So during my first week here, I was just playing with the IDV, trying to figure out how it worked, because if I'm going to be teaching people how to use it, I need to know how to use it. And I found this button to plot all of the National Weather Service warning polygons. And I was like, this is great. I can use this in my daily life. And I hit the button, and I got an error message. So I did some tracing back, trying to figure out where exactly the problem was. And it turns out that the Weather Service changed how they distribute their data files. So the type of file that we were looking for didn't exist where we were looking for it. They did still publish several other formats, or different file formats that included the warning polygons. And one of these is KML. KML is a version of XML. It's what's used by Google Maps. And I saw that KML was there. I saw that the IDV had several classes devoted just to reading KML files. And I was like, OK, this is perfect. So I go load a KML file into the IDV, hit plot, and nothing happens. Turns out that the KML file, or the KML reader file, was going through and it's saying, OK, is this an image? If so, plot the image. Is this a point? If so, plot a point. Is this a polygon? Nothing. So someone had started implementing this at some point in time. I'm not quite sure when, but had never finished it. So I went through and finished implementing that if statement, and fixed a bunch of other places in the code where things were hard-coded. So it was trying to read all of these as latitude, longitude, altitude. And so these are actually only latitude, longitude, latitude, longitude. So the second latitude point, it was trying to read as an altitude and made some kind of strange maps. But eventually I got that working. It took about 2 weeks because a lot of the time was just figuring out where in this 1.5 million lines I need to go insert those 30 lines that I actually need. But eventually it did what I wanted it to do, and I got a polygon plotted. Now, those of you with meteorology backgrounds will probably understand that the colors for these polygons matter. If you see a red flash flood warning, it just seems wrong. And I wanted this to be usable by the type of people who would be using it. So that meant that I needed to add color coding. I did that, but it was still only plotting one polygon at a time. And it's kind of a pain to go through and load each polygon, especially when you don't know how many polygons there are. Ewan and I spent a bit of time trying to figure out how to plot the groups. We got it so that you can plot all of the severe thunderstorm warnings, or all of the current tornado warnings, or even all of the current warnings. And even with all of the current warnings, I was very proud of this, it kept the color coding. That's how I made this plot. The biggest problem was times. Currently, what we have it set up to do is set the timestamp for all of the current warnings as the time that the file was downloaded. The KML files, for whatever reason, do not include the warning expiration time. And I didn't realize that until I was pretty deep down this hole. So we have something working that will show you what is current, but it can't tell you the past and it can't tell you the future. If you wanted to get those future times, another next step might be to actually go read the text files, the text warnings that the Weather Service puts out, and get the polygons from there. Another large part, probably the largest part of my work here, was making a series of tutorial videos to teach people how to use the IDV. I know several people who have tried to learn how to use it, like very talented professors among them. And they started, and they got frustrated, and they went and figured out how to do whatever they needed to do in Python or MATLAB. So my goal with making these videos wasn't just to help people learn how to use the IDV, it was to remove a lot of the stress and frustration from that process. Because if people are stressed and frustrated, we're not going to maintain our user base. Getting started was a little bit bumpy. It took me about a week to make my first video, which I'll show you in a few seconds. It was 1 minute and 18 seconds long. And it took me a whole week. And the audio quality wasn't great. I did everything I could to get feedback, or at least everything I could think of to do. I put together an email list of a bunch of friends of mine, classmates, people I'd met random places who said that they would be interested in seeing these videos and giving feedback. And every time I uploaded a video to YouTube, I sent these people an email. After about the 5th video, I still hadn't gotten any replies. So I gave up on that. UN did have me draft an email to send to the IDV users list, and I got one response from a guy named Walter Rogers. And I'll talk about him a little bit more later. He gave some good feedback. There was one part in the trajectories video that he was like, yeah, you weren't very, very clear on this. But he also had a lot of other questions. And the video series isn't done. There are currently 15 videos posted, but I plan to produce about 1 more video every week until the end of December.
I have a question. Did you get pushy and ask the people who didn't reply why they didn't reply?
Not individually, but as a group.
And what was the, is it just no response back?
Yeah. It was like shouting into the void. So I could have been a little bit more aggressive, but I also didn't want people to feel like they were being stalked by the IDV.
That's a great term.
So for the next part of the presentation, I'm going to be quiet, and I'm just going to show you a couple of the videos. The first one that you'll see.
You say it took you a week to make the minute and 10 second?
18 second, yeah.
18 seconds? Okay. How long did it take you to make the last one?
Now it takes me about 2 days to make a video that's about 5 to 6 minutes long.
Cool.
Which still sounds like a lot of time, but when you go in and you do the editing and you take out all of the loading time and you try to get good audio quality and you try to get good video quality and smooth cursors that don't jump all over the screen, there's a lot of editing time that goes into it and a lot of drafting time to plan what are you going to talk about, what data set are you going to use to demonstrate this, what exact displays are you going to create that will show this best. But I'm going to show you the first video and the 13th video that I made back to back, and I will just be quiet for this. Welcome to the first video in Unidata's updated tutorial series for the integrated data viewer. In this episode, we'll cover how to open the IDV on a variety of platforms. On Windows, it's very straightforward. During installation, you'll be prompted to create a desktop icon. Simply click on this icon, and the program is open. Mac is very similar. You go to Finder, search IDV, click on the icon, and there's the IDV. Linux is a little bit more complicated. You have to change directories to the folder that was created when the IDV was installed on your computer. If you're in the wrong folder, it won't work. Once you're in that folder, you type /run IDV, and the program will open. You'll know that the IDV is open when you see 2 windows that look like these. They may be arranged differently, one may be on top of the other, but as long as they're both there, you've done something right. If you're still having trouble getting the IDV up and running, check unidata.ucar.edu for frequently asked questions, or if your question isn't on there, email support-idv@unidata.ucar.edu and we'll get back to you as soon as we can. So our next topic is the GOES Lightning Mapper, or GLM. To get recent lightning data, go to the Satellite and Radar section of the Data Chooser. You can either click on the GLM button here, or you can go directly to the GLM Data Chooser using the sidebar. There are a few options here. The first is which data server you want to use. Unidata's ADDE server is generally a good bet. Then you have to choose the group. On this server, the options are real-time data from a GOES-R satellite or real-time data from a GOES-S satellite. Once you have the server settings, you can go ahead and connect. Some networks will block this connection. If yours is one of these, look for the upcoming ADDE Port 80 video in the IDV Advanced Topics series, or if you need to know the workaround before that video comes out, write to us at support-idv@unidata.ucar.edu. After connecting, you'll have to pick a GLM type. This part can be a bit confusing if you don't have a lot of experience working with lightning data, so I looked at this flyer online that explains the different options pretty well. The GLM defines an event as an occurrence of a single pixel exceeding the detection threshold during one frame. In layman's terms, this means that an event is a tiny speck of lightning. A group is a collection of simultaneous events close to each other, which would be one main branch of lightning if you were looking at it from the ground. A flash is a collection of groups close to each other in time and space. This would correspond to a lightning bolt. If each colored dot in this diagram is an event, then each of the smaller dashed ovals would be a group. The squares represent pixels. The GLM doesn't record exactly where within a pixel each event was, but it did recognize events in the lighter pixels. The red, blue, and green groups make up one flash. Now that we know what the options are, we can pick a GLM type. Flashes are probably the best to plot over a large domain. There are also a few time options that we need to specify. The first is the list of times to be used. There are two ways of specifying times, relative and absolute. Relative will let you retrieve near real-time data that updates automatically. Absolute will ensure that your data doesn't update until you're done working on it. The lightning data shows up best on the map if you make a point data plot. You can pick the icon to show at each data point. Fade by time lets you see multiple time steps in each frame and tell which flashes belong to which time steps. To take advantage of this, we should show multiple time steps per frame. Right now, the IDV takes quite a while to plot GLM data. This is because the GLM uses a timescale on the order of milliseconds, and each time step is stored in a separate data file. The IDV has to condense all of the files for your time step into a single display every time a display is created. In the future, Unidata plans to pre-process GLM data and publish it with longer time steps. This will remove a significant amount of the data processing from your computer so that you can generate figures faster. Decluttering hides some of the data so that you can see at least some of the individual data points instead of blobs of data points. There's a significant difference between high density and no decluttering. To see near real-time data, you can turn on polling. In the field selector, find your data source and double-click on it to open the properties. Click on the checkbox and specify how often the data should be reloaded. This is also where you can change the length of each time step, which is called bin size here. You are still limited to the number of time steps that you specified when you originally created the data source, but you can change almost any other property here. Each flash can also be described by parameters besides location. You can find a detailed description of the units and derivation of each parameter by following the link that I put in the description of this video. There are a few things that you can do with these fields. The most obvious is to plot them. I haven't shown you the Hofmahler display yet, so let's make one now. Everything's pretty much the same color, which kind of defeats the purpose of setting the color based on the energy intensity. To make the plot more useful, you may have to play around with the bounds of the color bar for a while. Another really useful thing that you can do with the gridded fields parameters is you can filter the point data. We can plot all of the flashes that have positive energy, or we can plot all of the flashes with energy greater than 1,000 microjoules per steradian per meter squared per micrometer. Now you know why I sent you to a paper for the units rather than explaining all of them myself. As I mentioned before, the GLM stands for Geostationary Lightning Mapper. It doesn't just give you information on where the lightning is, it can show you information about its path. The data set that I have loaded now isn't the same one that I had loaded earlier. I'm recording on a different day. We're going to add all three GLM categories to one map. Events can be first. I want an extremely small time step so that we don't have to worry about data points being hidden by the decluttering algorithm or overlapping excessively. We'll put the events on the map and then add the groups. These look just like the events, so we'll change the symbol. After plotting and changing the symbol for flashes, we can explore the data. I'm going to look for a good example in the Caribbean area. This cluster in Florida looks promising. After zooming in, we can see that the events are the most widely spread, followed by the groups. Events are great if you want an idea of the lightning's extent. If you're making the call on whether or not to delay the soccer game, the events are your best indicator of where the dangerous areas are. If you're comparing GLM data to surface station lightning data, you'll want to use the groups. They're the most similar to what most ground stations will detect. Lots of flashes can indicate strong updrafts. They could be useful if you're studying the relationship between lightning and storm strength. With this information under your belt, you should be ready to start using the GLM data in the IDV on your own. If you have any questions, visit our website at unidata.ucar.edu or email us at support-idv@unidata.ucar.edu.
Much better audio on that second one. Whatever you did on that second one, it was much better.
Was that audio compressed or you talk that fast?
She talks that fast.
Yes. That's actually the most consistent feedback I've gotten once I started actually getting feedback, was that the videos are very fast. And that was a conscious decision. I wanted these videos to be able to be used two ways. Either to get a broad overview of what can the IDV do with this type of data, or what is this display, or you can use it as a step-by-step tutorial. Now, with recording it quickly, if you want the step-by-step tutorial, you have to pause it a lot. But if I did it the other way and recorded it slowly,
You have to watch a bunch of them.
you have to watch a lot of time of video to get the broad overview. And I'm not sure how to balance this out, because you're not the first person who's had that reaction of, wow, this is fast.
I would have said that the piece that's missing there is, I have no idea how you could put it in, would be essentially a checklist box somewhere that says, okay, here are the things you need to hit. Here's the default value that you should probably use just to get something going, so that somebody can look at that as the reminder before they go into the video, or if they just want to come back. And if you in fact had a link that would take you into the right part of the video for that, it would help as well.
I may consider adding checklists to the
I
description.
have no idea how you'd integrate it with the video.
Yeah,
But
I think
something like that strikes me, because when I come back to it, I'm going to remember a lot of it, but not all of it, and I need that checklist to say, oh yeah, here's where I was, and here's what I need to.
And you can do easily link timestamps.
Yeah, okay, well then, then that would, having that checklist with the markers into the video, I would think would be an improvement.
There's also, I'll just say, I use this all the time. Whenever I watch a video on YouTube, I go to the settings and crank it up to 1.5, 1.75 or 2 times. If the person is speaking clearly, you can actually listen to stuff at 2 times the speed. And that's really useful.
Yeah, I did mention that in a response to a comment on one of the videos, except the opposite direction.
Yeah, right.
Dial it down.
0.75 speed.
That was good.
That was right.
This is, what Linux distribution did you use? Was that Ubuntu?
So the recordings here are, other than, the first video showed 3 operating systems.
Right.
But I did most of the video recording on Windows.
Well, the reason
But yes, it is Ubuntu.
The reason I bring up the Ubuntu thing is, and this is not for you, but it's something that we may just do as a courtesy in the future. You can create launchers in any of these Linux desktop distributions. So I can have a cute little button with the IDV and the planet and click on it and not have to worry about, oh my God, where did I install my IDV?
Yes, it is.
What's that?
All the different operating.
That's the problem, is that every desktop.
There's a standard for it.
We use install for J for that sort of stuff, and that should be possible if we're not doing it already.
Yeah, we're not doing it already. That's why I decided to make that video in the first place. Because the first time I tried to open the IDV on Linux, I was like, where is it?
Right.
And I had to spend a few minutes Googling to figure out how to open this program. So another,
Well, you did a Hubmuller plot of lightning data, is that right?
Energy.
yeah,
Is that, out of curiosity, is that scientifically meaningful to do a Hubmuller plot of?
I honestly don't know.
Because usually you do Hubmuller plots for things that are of a certain periodicity.
Change over
right?
time, yeah.
Yeah, that
Well, think about it.
was,
I mean, you can see a periodicity of lightning in the afternoon coming, who knows? It might prove scientifically valid. You can see a periodicity of the lightning.
Well, I mean, that's at a similar time of day,
Yeah.
day after day.
Yeah. Yeah, I think we already know that.
But, well, you know, okay.
So another part of my internship program is that I have to present a poster at a conference. Now, with what I've shown you so far, there's the getting polygons from the National Weather Service warnings to plot and making videos. I could make a poster on the polygons, but that would be kind of boring, and it represents less than a quarter of what I've been working on while here. I'm also going to, it's really hard to put videos on a paper poster. I'm not going to be at AGU with one of those fancy like computer screen posters. I have a piece of fabric that's printed out, it's hanging up in my office if anyone wants to see it. I'll also show it here. But so I had to try to find a way to incorporate multiple aspects of what I've been working on that didn't lend themselves very well to a traditional, here's the introduction, here's the methods, here's the data, here's the results. It's not your normal research poster. So.
It is colorful.
Oh, I forgot that this was turned off. I'm sorry for people listening on the recording.
I think this is great.
But so yes, I decided to lay it out as a general overview of the IDV. This way I can show people lots of different types of figures that you can create, including the polygons, which I can then go in and talk about, and the general framework for how they would go from their numbers to all of these pretty pictures. Hopefully, once they know that they can go from their numbers to the pretty pictures, they'll want to know how. And in a much more detailed way than this coarse representation. So I have links. And they're links for people with different levels of familiarity with the IDV. So if you're an absolute beginner,
Great idea.
you can start with, how do you open the IDV? What is the view window? What is the dashboard? If you already know that stuff and you want to get into how do I make these plots, you can jump into the intermediate topics. If you want to see, oh, Unidata made this really cool display that they've been using in their advertising, and I want to know how to make that, specifically the Hurricane Michael bundle. There's a separate series that's kind of like a quick start guide that just walks you through how do you make these well-known, cool-looking things. And then advanced topics doesn't actually have anything yet. That is going to be the port 80 video that I talked about, where a lot of networks will block access to the ADDE server, including CU Boulder, which is how I found out that that was a problem. There are also a couple things that I didn't put on this poster that Ewan wanted me to talk about to get a broad picture of everything I've done this summer. So this last part doesn't flow very well. But Walter, the person who I mentioned, who sent the email, gave me feedback, had trouble with transects, he sent me an email with about 9 bullet points, each about a paragraph long, all questions, things that he couldn't get to work, things that he thought were wrong with the IDV. And so we ended up setting up a conference call. Ewan sat in on that call, which was a good thing. Some of Walter's questions were fairly straightforward. His first one was the one that was actually video feedback. In the trajectories video, transects video, he didn't catch the part about how to delete transects that you aren't using. And so he had all sorts of red lines all over his map, and he didn't want them. So that was easy. I just walked him through, hey, you go to the transect manager, and you click on the one that you want, and you left click. You don't right click because there's no right click option, but you just click on it and highlight it and hit delete. That was pretty easy. He also had some questions that required a little bit of creativity to answer. He's trying to have a live display of the position of an aircraft, and it's reported as a CSV file. But he needs it to automatically refresh. And so he loaded in this CSV file, said, hey, IDV, this is a location, because you can tell the IDV what type of file you're giving it. And then he went to go set the polling, which is where it will automatically refresh, and there wasn't an option for it.
It's a CSV.
Because, well, not because it's a CSV, but because it's a location. Most locations don't move. And so the IDV doesn't have a way to make them move, because you would hope that most locations on the timescale that this is designed for are relatively stationary. But so I We walked him through how you would load it as just a plain CSV file, tell the IDV, hey, this is a CSV file, it has latitude, longitude, altitude, but it's not a location file. And then plot that, that can automatically refresh.
Did you go with the trajectory or did you just do?
He just, I think, wanted the point location. But that, whether it shows the actual path or not depends on the file that he actually has. He's working on some sort of field campaign where he's trying to break the altitude record by using stratospheric mountain waves to launch a glider.
That's
Been in our workshops.
Yeah, but he was one of the people who put the effort in to dig down and find the information that he needed about the IDV. And he actually emailed me directly. He didn't email the support address. He went to that, Jessica W at UCAR. He's like, I want an answer. Or 9 answers or 10 answers. And then the last kind of miscellaneous thing that I'm working on is there's a project called Drills Down underway. And it's for a Jupyter Notebook interface for the IDV. I've been doing some user testing and evaluation of this. It is still a work in progress. The first issue that I found was I have both Windows and Linux, but I started by setting it up on Windows. I got it all set up, and then I ran it, and it didn't work. Turns out it had never been tested on Windows before. There was code that was supposed to catch if it was Windows or not, but that code was flawed. So I wrote some code to fix that and gave that to Brian, who put it up on GitHub. But there are several other problems with the code. I'm compiling a detailed document of what's good, what's bad, what needs to be thrown out, what's great, and I'll get that to UN at the end of this week. And so that's where I am now.
All right.